Hey guys, so this is Ujjwal Kumar Sen and you are watching Ujjwal Kumar Sen English YouTube channel. So guys, in this video I'm going to discuss with you first law of thermodynamics, its consequences, applications, limitations, as well as I'll share some key points, formula as well, right? So let's start the session. So today I will discuss with you first law of thermodynamics, right? All right. So many of you maybe know the definition of first law of thermodynamics, the statements I'm talking about, but we'll try to understand this with different approach so that you don't need to cram it. You'll understand what is happening. Okay, are you ready? Let me show you. So first of all, if we are talking about first law of thermodynamics, we can find out or we can understand this concept using a system or an example, right? So let's say we have a system, and this is what, my dear, this is I am considering closed system. Here I am considering closed system. Now what we know from the equation of first law of thermodynamics, that is dq, or you can also say that q is equal to, there are in many books it is written dq, but in many books also it is written q is equal to du plus w, right? And here we are studying first law of thermodynamics in case of physics, that is engineering thermodynamics I am talking about, right? In case of chemistry, the sign convention will be different, so that I will not talk in this video. Now first of all, we need to understand all the points. What is the meaning of q, what is the meaning of du, and what is the meaning of w. Even you will find out in many books it is written like this: du is equal to q minus w. Why I have written this way, even you will understand right now. Okay, so what is the meaning of q? It is supply of heat, you can say that supply of heat into a closed system. So we have considered a closed system and we are supplying heat into it. Whenever we'll supply heat into it, there will be some changes taking place. So that is what, my dear, du, change in internal energy of this closed system. And because we are supplying heat into the system, so this system will do some work done into the surrounding, that is what w. From this equation we also come to know heat is not equal to work done. Heat is equal to change in internal energy plus work done. And one more thing I will make you understand in the consequences of first law of thermodynamics in this video only. I hope you understand what first law of thermodynamics wanted to tell us. That means there is conversion of energy taking place. One of the misconception we have, that is what heat is energy. No, it is not the case. Heat is the form of energy. Heat is the form of, you can say that one of the form of energy which is transferring because of temperature difference. Heat is not energy, right? It's a form of energy. You can say that it is happening because of temperature difference, right? Even we can understand about it much better way in second law of thermodynamics. I will tell it is the limitation of first law of thermodynamics that we cannot able to understand its direction. So if you want to ask me what are the limitation of first law of thermodynamics, there are major two limitation. One is we cannot able to understand direction of flow of heat. First. Second limitation is what? We cannot understand the quality of energy. Quantity wise we can come to know, quality we cannot. These two are the limitations of first law of thermodynamics, and these limitations we can overcome from second law of thermodynamics. I hope you can write down, right? These are two limitations. I will tell you example also, but examples there, I will tell you, just let me give you the definition. So what first law of thermodynamics, it states, what it states, right? It states that energy, right, energy can transfer from one form into another, right? It can transfer from one form to another. Let's understand this part. Right now you can see me because of light. Electrical energy is converted into light energy, so first law of thermodynamics is taking place. All right, I have got my point. If I can put the switch on the fan, right, so fan will start running. Even AC is still running. So what is happening? The energy conversion is taking place there also. So these are examples of first law of thermodynamics, even it is saying here. But one other part, let me tell you what is saying. Because of that, all the problems we are facing, right, because of first law. And when PMM1 said that also, PMM1 is opposite of first law, which is not possible obviously. So it is saying like this. Now energy can be neither created nor destroyed, right? So from first law of thermodynamics we got this definition, we got this formula. So far I have shared two things about first law of thermodynamics. Now even the third one I have shared limitations. Now I will share with you two more things regarding first law of thermodynamics. One is what? Consequences. We'll talk about two consequences of first law of thermodynamics. Then I will tell you few important points of first law of thermodynamics. Those will be important for your competitive examination. So let's talk about consequences of first law of thermodynamics, right? So let me just erase or drop all these things. So there is some problem. Okay, no problem. Next time I have to put some water so that it will work quite comfortably. Okay, no problem. I have to put little bit more pressure so that it will. Okay, now so let's talk about consequences, right? So two parts I'm just separating, right? So here I'm talking about first consequence, right? Consequences. So consequence first, and this one is consequence second. First of all, let's understand what is the meaning of consequence. All right, so let me tell you, my dear, consequence means outcome. So there are two outcomes we are getting, or result we are getting from first law of thermodynamics. One is what? Consequence one. What is saying basically, for closed cycle dq or dw, w is equal to q for closed cycle, right? It can be possible, it is saying only for closed cycle. It can be written like this: summation of w is equal to summation of q. We can also write like this. Now what is saying? Cyclic change q is equal to w, and w is equal to q. But one most important thing also we come to know from here. I will show you that. until we study first law of thermodynamics, we come to know that is what work done is a path function, but we don't know heat is also a path function. From here we can able to understand how heat is also a path function, right? So let's get into it. So let me draw a diagram, that is pressure and volume diagram. So here we are getting points and I am taking two process here, one process here. So let's say this is point 1, this is point 2. So process like this, let's say this one is A, this one B, and this one C. Alright, so I hope so you can see this. Now from here we can write the equations. I hope so you can see here. Alright, so let me write equation. These equations are really important for me to make you understand regarding this. So let me write like this: Q1 B2, Q1 B2. So for this case I am not considering A1, I mean A part, that is 1A2. I am not considering this process, I am considering only B and C, plus Q 2C1 is equal to W 1B2 plus W 2C1. Alright, so is it correct? I have written like this: heat is equal to work, and closed system we are considering, right? It is only happening because of closed cycle. I must say that, not closed system, closed cycle. So if we'll consider now 1A2, not 1B2, so we can write the equation like this: Q 1A2 plus Q 2C1 is equal to Q1A2 plus W2C1. It's so simple to write. Now here we will apply, my dear, very simple concept of mathematics. We'll change the sign of the equation 2. Let's say the upper one is equation 1 and the below one is equation 2. So we're going to change the sign of equation 2. So I'm changing the sign, right? I'm doing like this. Alright. Now as you can see from here, this one and this one will get cancelled. They will eat each other. This one and this one, they will eat each other. Even if you'll see here, this one and this one, they also will eat each other. So what we remain from here, let me write down properly, that is Q1B2 minus Q1A2 is equal to W1B2 minus W1A2. Is it okay? So from here what we are getting, let me tell you, my dear, from here we can say that W1B2 minus W1A2 is not equal to 0. That means also we can say this: W1B2 is not equal to W1A2. What is the meaning of this? That both are not equal. That means they are not depending on point, they are depending on path. Because paths are different, that is why the values are different. That is why their values are different. That means work done or work is a path function. Are you getting my point? The same thing we can also come to know from here, the same thing, heat, that is, let me write down once again somewhere, Q1 B2 minus Q1A2 is not equal to 0. That means we can say that Q1 B2 is not equal to Q1 A2. That means once again paths are different, that is why both are not equal. That means heat is also a path function. Got my point? Got my point? Now let me show you few key points regarding heat and work. Both are path function. That is why heat and work both are inexact differential. Remember this. Heat and work both are inexact differential. Now what are exact differential? Properties are exact differential. And what are the properties? Basically the two types of properties, intensive property and extensive property. One of the property we are going to get from consequence 2 of first law of thermodynamics. Listen to me very carefully. If you understand this, my dear, what I am writing, you don't need to cram anything, because I am showing you everything right now, how it is happening. From this fact you come to know how heat is a path function. From here also come to know how work is a path function. It's not a point function, because they are depending on path. That is why they are inexact differential. Their cyclic, you can say that variable, the cyclic variable is not equal to 0. Change in cyclic variable is not equal to 0. If it is equal to 0, then it is exact differential. They are properties. Like pressure is a property, energy is a property, temperature is a property, volume is a property. Got my point? Now let's move on to the consequence 2. So what consequence 2 is saying? What it is saying to us? Energy is a property. Now how is it possible? How we can able to apply this? How we can able to prove it? Let me show you. So it is saying, what is saying? Energy is a property. All right. So it is saying energy is a property. All right. So we have time, I think. So yeah, we have time. Now I am considering only the equation that is written here. So Q1B2 minus Q1A2 is equal to W1B2 minus W1A2. I hope so you can see till here, right? Yeah. Now we are arranging, basically we are doing something like this. We are arranging like this. We are separating, right? Let me write down, you can understand also. B2 minus W1B2 is equal to Q. So this should be like this. Yeah, we can say that Q1A2 minus W1A2. Now we can write like this. Q minus W1B2 is equal to Q minus W1A2. All right. So if we will increase another path by, let's say, D, so we can say like this, ABD. Yes, Q minus W1D2. What is the meaning of this? They are equating, they are equal. Doesn't matter which path they are following, the values are equal. You can see for A is equal to B is equal to D. So doesn't matter which path they are following, the values are equal. That means they are not depend on path. And is equal to what we can write, basically dE. What we can write? dE. And energy is what, my dear? It is a property. What type of property is this? Extensive property. Why it is extensive property? Because it is depend on mass. If anything in the world is depend on mass, is known as extensive property. If anything in the world is, if it is property, right, and all the properties are point function, you can say that it is depending on point, not path. Its value is depend on point, not path. So guys, let's talk about few more important key points regarding first law of thermodynamics. Well, so the equation we are getting, this equation, this is applicable for reversible and irreversible for both the processes, right? It is also, I have written here, this for all the process, reversible as well as irreversible process. And this energy is what, my dear? Energy is a property, and all the properties are depend on point function. It is not depend on path, right? All the properties are point function. But if we'll further go into types of properties, so there are two types of properties. One is intensive property, another one is what? Extensive property. So if you talk about energy, energy is an extensive property, E for E. If we'll go into the definition of extensive property, if anything which is depend on mass is known as extensive property, like energy is an extensive property, right? Heat is not a property, heat is a path function. Work done is not a property, work is a path function, but energy is a property. Temperature is a property, but energy is an extensive property. Temperature is an intensive property, because temperature is not depend on mass. Now let me give you an example of property. Things will be quite amazing for you. So we know the density, right? Density, right? Formula of density is what? Mass division volume. All right. If I'll ask you, maximum of you are going to tell me this is an extensive property because it is depend on mass. But my dear, it is not an extensive property, it is an intensive property. And because of this, in so many competitive examination, I'm talking about MCQs, I have seen this question asked, density is an extensive property or intensive property. So what the students make mistake, they just write down the formula to figure out whether it is intensive or extensive, and they make mistake that just write down it is an extensive property because mass is there. But we are making mistake, that is what? It is, mass is of course an extensive property, but volume is also an extensive property. If there is any term like density, it is equal to extensive property division extensive property, then that term becomes intensive property. That is why it is an intensive property, not an extensive property. Like density, we have pressure. We have pressure. Pressure is also what, my dear? An intensive property, because pressure is equal to force division area. Area is an extensive property, right? And on the above, force is an extensive property because force is equal to mass into acceleration. I hope you got my point, right? So that's it for today's video. Thank you very much for watching this video. In my next video, I will talk about second law of thermodynamics. Thank you much for watching this video. Like this video, share with your friends, and if you are new to this channel, do subscribe to this channel. Bye bye. Thank you very much. God bless you all. Bye.